Did you think it was going to be that the whole video? No, of course. I'm here to teach you. Alright, so we have isosceles triangles, and if we go back, equilateral triangles, two main topics in section 5. So isosceles triangles, you may know about these a little bit. It has two congruent sides, which are called the legs. And the third side down here is called the base. And the two congruent sides form the vertex angle right up here. And the two other angles form base angles, which you'll see all of this located here. Alright, we have a decent amount of theorems here. We start with theorem 4-3. A lot of them are pretty quick though, so don't get too worried there. Theorem 4-3, isosceles triangle theorem. If two sides of a triangle are congruent, which of course that's an isosceles triangle, then the angles opposite of those sides are congruent, also known as the base angles. So if we have a picture like this, we have two sides here congruent, then the angles opposite will be congruent. And you see that here, angle A congruent with angle B. Alright, then the converse. Converse, that's where you wear your shoes flipped. So, what do you think I do with the two statements? Well, I just flip them. If two angles of a triangle are congruent, so we might start with this down here, angle A congruent with angle B. Then the two sides opposite of the angles are congruent. So this side with this side. And that kind of makes sense. And again, just to figure out which one is the converse, which one is the regular theorem, if we just go back, what is an isosceles triangle? Well, it has two sides congruent. So that's what you're going to start with for the isosceles triangle theorem. Alright, theorem 4-5. This one's a little bit different than the other ones. We have the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So again, bisector of the vertex angle. Well, here's an isosceles triangle. And then the bisector of the up here's the vertex angle. Notice how that angle is bisected, split into two congruent angles. And then it says, let's make sure we have the next part. Of an isosceles triangle. First off, do we have an isosceles triangle here? Yes. So then that means that this line is the perpendicular bisector of the base. Here's the base. So that means we'll have this perpendicular, which means there will be two right angles, and then AD congruent with DB, since CD bisects the segment AB. Again, so let's go through that one more time. The bisector of the vertex angle, so right here, this line's the bisector, is the perpendicular bisector of the base. So anytime this line here bisects these two angles, this line will be the perpendicular bisector of the base. Okay, good. Alright, now we have corollaries, which just follow immediately from theorems. So corollary to theorem 4-3. This is with equilateral triangles. So if a triangle is equilateral, which we have here, then the triangle is equiangular. And take a guess what equiangular means. Let's see, angular. Well, yeah, you guessed it. That means that the angles are equal. That's a funny word, actually. Angular. So all three angles in here will be congruent. And you could guess what the next one will be. Corollary to theorem 4-4. If a triangle is equiangular, then the triangle is equilateral. So here we have three congruent angles. What do you think will be true about the three sides? They're congruent, of course. And here's just a few practice examples. Let me start with this one here. Let's see, 110 degrees, and then we have two equal angles here. So what's left over for the triangle? There's 70 degrees left over, 180 minus 110. And then if both angles are equal, they'd both have to be 70 divided by 2, which is 35 degrees. So x is 35, and y is 35. And you could go through a few more of these. How about you try number 5? This is a good one to try. And number 2, we'll say. So number 2 and 5, I'd write those down and give it your best try, and we'll check it tomorrow in class. Thank you for listening. I'm very, very grateful. Have a great day.